I bet you didn't know how crucial computer networks are to your daily life. Hey there, tech enthusiasts. Welcome to ARYSEC. I am your host, Aryan Giri, here to break down a fundamental concept: computer networking. In essence, it's the magic that allows your devices to talk to each other and share information. Imagine a digital highway where data packets zoom around, connecting computers, smartphones, and even smart refrigerators. Cool, right? Networking is the backbone of our modern digital lives. It enables us to browse the web, stream our favorite shows, and collaborate on projects from anywhere in the world. Without it, we'd be stuck with isolated devices, unable to harness the power of interconnectedness. Think about it. Every time you send an email, upload a photo, or join a video call, you're tapping into the power of computer networks. Pretty amazing, huh? So buckle up as we dive deeper into this fascinating world, exploring the nuts and bolts that make it all work. Welcome to ARYSEC. I am your host, Aryan Giri, and today's topic is computer networking basics. This is gonna blow your mind. Let's break down the different types of networks you might encounter. Think of it like this. Networks come in various sizes, each with its purpose. First up, we've got PAN, or Personal Area Network. This is your own little network bubble, connecting devices within a very close range, like your phone, headphones, and smartwatch. Next is LAN, or Local Area Network, which connects devices within a limited area, like your home or office. Think of all the devices connected to your Wi-Fi router. That's your LAN. Moving up in scale, we have MAN, or Metropolitan Area Network. These networks span a larger geographical area, like a city or university campus. Then there's WAN, or Wide Area Network. This is where things get really interesting. WANs cover a vast geographical area, often connecting multiple LANs across countries or even continents. The internet itself is a prime example of a WAN. Finally, we have VPNs, or virtual private networks. These are like secure tunnels through the internet, allowing you to access private networks remotely while keeping your data safe and sound. Just like you need an address to receive mail, devices on a network need a unique identifier to send and receive data. That's where IP addresses come in. An IP address is a numerical label assigned to each device connected to a network. Think of it as a digital home address for your computer or phone. It allows other devices to locate and communicate with it across the network. There are two main types of IP addresses, IPv4 and IPv6. IPv4 uses a 32-bit address space, while IPv6 uses a whopping 128 bits. This means IPv6 can handle a mind-boggling number of addresses, which is essential in our increasingly connected world. Without IP addresses, it would be chaos. Imagine trying to send a letter without knowing the recipient's address. It wouldn't work. IP addresses bring order to the network, ensuring data gets delivered to the right place. Now imagine a large office building with hundreds of employees. To make things more organized, you divide the building into departments, right? That's kind of what subnetting does for networks. Subnetting is like dividing a large network into smaller, more manageable segments. It helps improve network efficiency and security by controlling data flow within specific areas. But how does data actually get delivered to the right application or service on a device? That's where ports come in. Ports are like numbered doors on a computer, each designated for a specific type of communication. For example, port 80 is commonly used for web traffic, HTTP, while port 25 is for sending emails, SMTP. By specifying the port number, data packets are directed to the correct application, ensuring smooth and efficient communication. Pause 3S, navigating the network maze. Picture your data as a car on a road trip. Just like a car needs a map and directions to reach its destination, data packets need routing protocols to guide them through the complex network landscape. These routing protocols are the unsung heroes of networking, ensuring that data takes the most efficient path to its destination. There are several types of routing protocols, each with its own set of rules and algorithms. For example, OSPF, or Open Shortest Path First, is like a GPS that constantly updates the best route based on current traffic conditions. It dynamically adjusts the path to avoid congestion and ensure timely delivery. Another common protocol is BGP, or Border Gateway Protocol, which is like a travel agency that plans the best international routes, enabling data to traverse different networks across the globe. These protocols work together to create a seamless and efficient data delivery system, optimizing the flow of information across vast and intricate networks. By understanding how routing protocols function, you can better appreciate the complexity and sophistication of modern data communication. Now let's dive deeper into the mechanisms that make these protocols tick and how they keep our digital world connected. Pause 3S. Next, we'll explore the tale of two protocols, TCP and UDP, and how they shape data transmission. Section 5, TCP versus UDP, a tale of two protocols. In the world of networking, TCP and UDP are two heavy hitters when it comes to data transmission protocols. They determine how data is packaged and sent across the network. Think of them as two different shipping methods. TCP, or Transmission Control Protocol, is like a reliable courier service. It ensures data is delivered reliably and in order. It's like sending a package with tracking and delivery confirmation. TCP is used for applications where data integrity is crucial, like web browsing, email, and file transfer. On the other hand, UDP, or User Datagram Protocol, is like sending a postcard. It's faster and more efficient, but doesn't guarantee delivery or order. UDP is used for applications where speed is more important than perfect accuracy, like online gaming, video streaming, and VoIP calls. So there you have it. TCP for reliability, UDP for speed. The choice depends on the specific application and its requirements. Section 6. HTTP and beyond. Speaking the language of the web. Ever wondered how your web browser talks to websites and retrieves information? That's where HTTP comes in. HTTP, or Hypertext Transfer Protocol, is the foundation of the World Wide Web. It's the language that browsers and servers use to communicate and exchange data. When you type in a website address, your browser sends an HTTP request to the server hosting the website. The server then responds with the requested content, which is displayed in your browser. HTTPS is like HTTP's more secure cousin. It encrypts the communication between your browser and the server, protecting your data from eavesdropping and tampering. Look for the padlock icon in your browser's address bar to verify that a website uses HTTPS. But wait, there's more. Other essential network protocols include FTP, File Transfer Protocol, for transferring files between devices, SMTP, Simple Mail Transfer Protocol, for sending emails, and IMAP/POP3 for receiving emails. Section 7, Network Devices, keeping your data flowing. Now let's meet the hardware heroes that make networking possible. These devices work tirelessly behind the scenes, directing and managing data flow across networks. Routers are like traffic directors, connecting different networks and forwarding data packets to their intended destinations. They use routing tables to determine the most efficient path for data to travel. Switches are like network hubs, connecting devices within a LAN and forwarding data only to the intended recipient. They learn the MAC addresses of connected devices, creating a more efficient network. Firewalls act as network security guards, filtering incoming and outgoing traffic based on predefined rules. They protect your network from unauthorized access and malicious attacks. Modems are the bridge between your network and the outside world, converting data signals between your devices and your internet service provider. They allow your devices to connect to the internet and communicate with other devices globally. Section 8, OSI and TCP/IP models. Understanding network layers. To understand how networks function as a whole, we need to talk about network models. These models provide a framework for understanding the different layers of network communication. The OSI model, or Open Systems Interconnection Model, is a conceptual model with 7 layers, each representing a different aspect of network communication. Think of it as a layered cake, with each layer performing a specific function. The TCP/IP model, or Transmission Control Protocol Internet Protocol model, is a more practical model with 4 layers, closely aligned with the actual protocols used in computer networks. It's like a simplified version of the OSI model, focusing on the essential layers for internet communication. While both models have their differences, they share the same goal: to provide a standardized way to understand and troubleshoot complex network interactions. Section 9. Networking in action, real-world applications. Networking is everywhere. It's the invisible force that powers countless aspects of our daily lives. Let's say you're video chatting with a friend overseas. Your voice and video data are converted into packets, routed through various networks, and delivered to your friend's device, all in real time. Or imagine you're shopping online. You browse products, add them to your cart, and enter your payment information, all securely transmitted over encrypted connections thanks to HTTPS. Networking also plays a crucial role in businesses of all sizes. From small offices to global corporations, networks enable collaboration, communication, and data sharing, boosting productivity and efficiency. The Internet of Things, or IoT, is another exciting area where networking shines. IoT devices, from smart home appliances to industrial sensors, rely on networks to communicate and share data, creating a more connected and intelligent world. Section 10. Conclusion. Stay connected with ARYSEC. And there you have it, a crash course in computer networking. We've covered the basics, from different network types to essential protocols and devices. Remember, networking is the backbone of our digital world, connecting us and enabling countless possibilities. Whether you're browsing the web, streaming your favorite shows, or collaborating on projects, understanding the fundamentals of networking empowers you to navigate the digital landscape with confidence. Stay tuned for more insightful tech breakdowns from ARYSEC, your trusted source for all things tech.